The last class in our example is the BasePlusCommissionEmployee class, which you can see defined here on line 4. This class extends CommissionEmployee, which means we can say that every object of class BasePlusCommissionEmployee is a CommissionEmployee and therefore is also an employee, because CommissionEmployee extends employee. That also means that anything that was declared as a public method in class employee or class CommissionEmployee is now considered to be a public method of our new class BasePlusCommissionEmployee, and all of the private data from the classes throughout the hierarchy is used to make up the complete in-memory representation of a BasePlusCommissionEmployee. So a BasePlusCommissionEmployee first consists of the strings, first name, last name, and social security number that were indirectly inherited from class employee. That's followed by the gross sales and commission rate variables that we inherited from class CommissionEmployee, and that in turn is followed by the private piece of data called base salary that we're declaring here on line 6. Now remember, the first 5 of those pieces of data were declared private in their respective classes, so I can't use them directly in the body of this class without first going through one of the set or get methods that we're inheriting from our direct and indirect superclasses. Now, as with our other classes, we do have a constructor, and our constructor here receives 6 different parameters, the first 5 of which are immediately passed to the superclass CommissionEmployee's constructor. When you define a constructor for any class, you're only required for making an implicit or explicit call to the immediately preceding superclass's constructor. Well, the immediately preceding superclass is CommissionEmployee, and its constructor requires 5 arguments. And then the CommissionEmployee constructor is responsible for taking the first 3 of these and passing them up to class employee's constructor. And by the way, even though we didn't say anything about it, class employee's constructor implicitly calls class object's constructor to initialize any data that's inherited from class object. Once that happens, then class employee's constructor finishes its job. That would return to class CommissionEmployee's constructor, which will finish its job, and then we'll return here to line 13 to set the base salary. As in our previous version of this class, we have set and get base salary methods plus all of the other set and get methods that we've inherited. And down here at line 29, we have the earnings method, which now takes on special meaning because of the fact that the earnings method is defined in class employee with the exact same public double earnings empty parentheses. So I'm now once again overriding how to calculate the earnings, but this time for a different class in the hierarchy. So whenever I get ready to calculate earnings for a BasePlusCommissionEmployee, what I'm going to do is call the superclass employee's earnings method, which will get me the gross sales times the commission rate. Then I'm going to add to that my base salary, and together those form the complete earnings that I will return. Also, we've got a toString method here, which, as you can see, calls the superclass's toString method. Now remember, we have a toString method in class CommissionEmployee and a toString method in class employee. This is calling the one from class CommissionEmployee because the only one you have access to in Java that is not explicitly defined in your class is the most recently defined one in the classes above you in the hierarchy. So in my case, the most recently defined toString above this class is the one that we inherited from class CommissionEmployee that we just looked at a little while ago. So for our new toString method, we're going to start by using the string base salaried. Then we're going to call super.toString, which will get me the CommissionEmployee representation of a string. And at the very end of all of that information, we'll add on the base salary data. Now, before we go on to take a look at our test program, let's go back and talk about the earnings method one more time in the context of the BasePlusCommissionEmployee class. As you recall, this method back in class employee was declared as an abstract method. Now, because it's declared as an abstract method in class employee, every single class below class employee in the hierarchy is required to have an earnings method that takes no parameters and returns a double. Now, if any one of the classes below class employee in the hierarchy inherits that abstract method and doesn't redefine it, then that class would also have to be declared abstract. So my question to you is, if you were to remove lines 29 through 32, would the class BasePlusCommissionEmployee that we're currently looking at be an abstract class or a concrete class? And you need to think about that carefully. When I ask that question in my typical Java seminar that I teach on site at companies, about 50% of the people say this will be an abstract class, and 50% of the people say it will be a concrete class. And the answer is that it will be concrete. And the reason for that, once again, is that you always inherit the most recently defined version of a given method. Well, if I don't define earnings here, then my BasePlusCommissionEmployee class still gets the version of earnings from class CommissionEmployee. It won't do the correct calculation because it won't include the base salary, but it is still a concrete implementation of that method. So if I don't define it in class BasePlusCommissionEmployee, the class will still be a concrete class because we're inheriting from class CommissionEmployee, and in that class we provided a concrete implementation of the earnings method. We're now going to move ahead and take a look at the test application.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.